Hello, today we will discuss Wilson's theorem and inverse reminders mod p. Wilson's theorem tells us that if we are given prime number p, p minus 1 factorial equals -1 mod p. And what is inverse reminders? Every fraction can be written as the some number modulo p, some integer number modulo p. If we discuss something like 1 over a times a, this number is always 1 mod p. So if we want to somehow define what will be a times a 1 over a, we need to look for a number which will take a to 1. So now we already know that a to the p minus 1 equals 1 mod p if a is not multiple of p by using the Fermat's little theorem. So if we are given a and multiply this number by a to the p minus 2, we will see that their product will be always 1 mod p. So we have proved that 1 over a is equals a positive integer mod p, and this integer must be a to the p minus 2 mod p. This inverse reminders has very beautiful characteristics also, but today we will discuss that if we are given numbers 1, 2, up to p minus 1, for each number a, there will be only one number b, such that a times b must be equal 1 mod p. So if we found the number b for a, for b the inverse remainder must be a. At first we need to show that there will not be any other solutions except b. If a times c is also 1 mod p, we can take their difference and we will get a times b minus c equals 0 mod p. And clearly this must be contradiction, because a is not multiple of p and b minus c is less than p. So their product can't be multiple of p. So there will exist only, at most, only one b. And now we can show by using that if b equals a to the p minus 2 mod p, such number will always exist. Now look at the numbers whose inverse equals itself. For example, if we are given number d square equals 1 mod p. What can we say about this number? We can take 1 to the left hand side and we get that d minus 1 times d plus 1 must be equal 0 mod p. So we have concluded that only two possibilities we have for d. The first one is d equals 1 or d equals -1 mod p. Now we can show that if we group all these numbers from 1 to p minus 1, 1, 2, up to p minus 1, a will be grouped to itself. For 2, we need to find some integer for whom 2 times this one, called c, 2 times c, must be 1 mod p. So we can group all these numbers, and we will see that there will not be any intersection, because we have already shown that a times b is the unique pair. Their product equals 1 mod p. But we are left only this integer without any pair, and 1 also. So if we take all these pairs, product of these pairs, all of them equals 1 mod p. And we need to multiply this by 1 and p minus 1. We will have p minus 1 over 2 pairs whose product equals 1 mod p. So p minus 1 factorial must be equal 1 to the p minus 1 over 2 times 1 times p minus 1. And clearly this is p minus 1 and equals negative 1 mod p. And so we have proved Wilson's theorem. If you want to discuss some new theorems, please write in the comments.